Alright guys, so now we have here the surface area of composite solids. So I hope this brings back memories when you guys were doing composite figures, just the regular area. And remember how on composite figures, all we did is we broke up the figure into its most basic shapes and we found the areas, and then that was it. And then we added them up. So it's the same concept here, but now there's one more thing you have to keep in mind. For example, in this picture right here, yes, we have a cylinder and a hemisphere. That's what it's called when it's half a sphere, hemisphere. Okay, so again, yes, we have a cylinder, and again, all I'm doing is I'm breaking it up into the two different shapes that I saw. A cylinder and my hemisphere. Okay. And yes, basically all I need to do is find the surface area of each one and then just add them up. But there's one small thing that I want you to keep in mind. Here, the area here, where this one lies on top of this, is not being exposed as a surface. So you just have to keep that in mind. So when you're about finding the surface area, just be careful. For example, in a cylinder, the surface area of a cylinder normally is your perimeter times your height plus 2b. But in this case, because this one is not being exposed, right? We are only going to consider one base. And so my formula in this case, I'm going to alter it a little bit to consider that, and instead I'm only going to have one base. Please make sure you understand that. And again, the reason for that is eventually when this figure here lies on top of this, it's going to be hidden and you won't see it at all. It won't be exposed. So perimeter, remember in a cylinder was just that pi r, 2 pi r. So this is 2 pi r. My radius, this is 12, so my radius is 6. The height is 13. And in a cylinder, right, it's a circular base, so pi r squared. So pi, to get b, is going to be pi r squared. So pi times 6 squared. So pi times 6 squared. So big B, the area of the base, is 113 basically. And when I calculate all of that, 2 times pi times 6 times 13 plus 113. The surface area of the cylinder that's being exposed is 603. Now onto the hemisphere. Well, again, normally in a hemisphere, the surface area was, I believe it was 4 times pi r squared. But let's find out, right? We have our formula sheet we could always look at. And again, to access our formula sheet, you just go to the geometry one, go to files, and it'll be the one called a star geometry formula chart. Or you could always Google the formula, right? So again, the surface area of a sphere, it's going to come out shortly on mine, is 4 pi r squared, yes. My radius is the same as the radius over here, so my radius was just 6. So this is just 4 pi 6 squared. Also, keep in mind that this is for a full circle, so what we're going to have to do is we're going to have to divide this by 2, because I just want half, okay? And no, I am not going to bother with this bottom part either because it's not being exposed at that point. Again, the 4 pi r squared only gives you the outside. Okay, if I had an actual hemisphere, it would be that plus the circle on the bottom, but I don't have to worry about that here. All right, so it's just 4 times pi times 6 squared, and then that divided by 2. So the surface area of the hemisphere is 226. I'm just going to round it up to say 0.2. And if I wanted to find the total surface area, I just have to add up those two values. When I add up those two values, 603 plus 226.2, I get that the total surface area was 829.2. It's the same concept for the one right underneath. You can notice how there's two different shapes. We have a rectangular prism where we know that, and again, it just depends how you see it, but the 3 sides that are important here are this 4, and this 5. And we have a triangular, a pyramid. And since this pyramid is right on top of this must be a square / rectangle pyramid. Now looking at this, since this is 4 and this is 4, this is actually a square pyramid. So we have a square pyramid. And again, we just have to now look at our formulas to see how we find the surface area. But it's the same thing here, where the base is not being exposed. So in my pyramid, all I need to really worry about is my lateral area, and that's it on the pyramid. In a pyramid, the lateral area is 1/2 my perimeter times my slanted height. In this rectangular prism, surface area is perimeter times height plus 2b, but again, one of the bases is not being exposed, so it's just going to be 1b. Please understand why it's not 2b. All right, so for the figure here, this is my base. So in my perimeter, the perimeter of my base happens to be 4 plus 4 plus 4 plus 4, which is 16. The area of my base, because everything's 4 times 4, it happens to be 16 as well. And the height here is 5. So I have enough information to substitute here. It's going to be 16 times 5 plus 16. When I'm working on this one, they give me my height. That's what this represents. So I know that's 6. Here. And you know that this is 4. And again, this right here is just going to be half, so it's 2. Since we need L, and L is our slanted height, we have a right triangle. I don't know if you see it right there, where you know this is 6, this is 2. So we're going to do Pythagorean theorem. The perimeter here, again, is the same. Perimeter is 16. So now we can come and get our calculator. Again, these are just little puzzles. That's all it is. Think of them that way. 16 times 5 plus 16. So in my rectangular prism, the surface area being exposed, including the bottom part, but not this top part, is 96. And over here, I need to do Pythagorean theorem first to find my slant height and be able to calculate it. So 6 squared plus 2 squared. Again, we're adding because we are looking for the hypotenuse. So my slanted height is 6.3. And now I could just plug it in. So it's going to be 1/2 16 times 6.3. And I'm going to get a surface area, or in this case lateral area, because that's all that's being exposed, of 1/2 times 16 times 6.3, 50.4. And again, if I want to find the total, all I have to do is just add, and that's it. Now notice how the word total is not included, but it's implied. The only time we do lateral is when, one, it's a real world problem in this case, right, where there's no way you could get the total, or if they specifically say find the lateral area. But right now it's total, so it's just going to be 96 plus 50.4. So the surface area here is 146.4. That's it, guys. That's how you treat these composite solids, very similar to composite figures.